Hi guys, good day everybody. Welcome to chemistry class with Anselm. Yesterday we looked at the Luzak's law of combining volume. Today we are going to look at Graham's law of diffusion. But before we go on, we are going to know the meaning of diffusion. Diffusion of a gas is the spreading of the gas or movement of gas particles from the area of high concentration to the area of lower concentration until there is a diffusion equilibrium. That is, until there is equal spread within the two areas. So, if you look at this diagram, it shows exactly what diffusion of a gas entails. The first place, number one, we have a gas A. You can see that this gas A is in this particular area and is highly concentrated. And in this second area, there is no gas there, meaning that there is no diffusion. Diffusion has not started. Since diffusion is the movement of gaseous particles, there is no movement, it's evident here. There are two areas. In this area, there is gas A. In this area, there is no gas. So there is no diffusion in the first place. Now look at the second diagram. You will see that in this area, we still have gas A, and in the other area, there is gas A there. But it seems the concentration here is greater than the concentration here. Meanwhile, the gas is just moving to a new area. The gas is gradually spreading into a new area, which means there is diffusion. Diffusion starts here. This diffusion continues until there is equal concentration between the two areas. As you can see in the third place, we have gas A here, and we have gas A here, and they have equal concentration. There is equal distribution within the two areas. Therefore, diffusion equilibrium is attained here. So that is the concept of diffusion. So now let's look at Graham's law of diffusion proper. Let's look at the law proper. Let's look at the law. Now, Graham's law of diffusion states that the rate R of diffusion is inversely proportional to the square root of its vapor pressure. Square root of its density. D. That is the law. So mathematically, we can see that Graham's law is trying to say that R is inversely proportional to the square root of the density. That's what is the density of the gas. So this is the mathematics. So removing the variation sign, we can say that R is equal to K times 1 over square root of d, where k is the constant of proportionality. Now, if we have two gases, gas 1 and gas 2, the rate of diffusion for gas 1 is equal to K1 times 1 over square root of d. That is d1. This is equation 1. And we can say that R2 for gas 2 equals K2 times 1 over square root of d2. And this is equation 2. We are trying to compare two gases. Now, making K1 and K2 the subjects of the formula, we can now have from equation 1 that K1 equals R1 divided by 1 over square root of d1. And we can say that K1 equals R1 times d1 over 1. And we can say that K1 equals R1 square root of d1, the bare square root. R1 times square root of d1. So we can say that this is our equation 1, modified equation 1. And we can now say that K2 equals R2 times square root of d2. Equation 2 modified. But you should know that K1 is the same thing as K2. They are constants because constant does not change. If that is the case, we can now say that equation 1, since K1 is this and K2 is this, equation 1 is equal to equation 2. And we can say that R1 square root of d2 equals R2 square root of, R1 square root of d1 equals R2 square root of d2, since K1 is equal to K2. Now, coming to this point, it's just like writing 2x equals 3y or 2x equals 4y. You can now say that x divided by y, x from here, divided by y from here, will give you 4 from here, divided by 2 from here. So that if you clear the fraction, you can now say y times 4, or x times 2, x times 2, x, 2x, y times 4, 4y. You get back to this equation. So this is exactly what we are going to apply here by saying that R1 from here divided by R2 from here will give us square root of d2 from here divided by square root of d1 from here. Let's call this equation 3. This is our equation 3, and this is the law, Graham's law of diffusion. Now, going further, we can modify that law mathematically. We can modify this particular law mathematically. Recall this. Recall that rate is reciprocal of time. Remember, rate of doing work is compared with the time. If you are faster in doing work, it means you are using shorter, smaller time. But if you are very slow in doing work, you are using more time. So, rate is equal to reciprocal of time. We can now say that R is equal to 1 over T, which means R1 will give us 1 over T1, which means the first rate of gas 1 is inversely proportional to the time of the diffusion of gas 1. This is a given. We can also say that R2 is equal to 1 over T2 also. Let's call this equation 4 and this equation 5. Now we are going to substitute equations 4 and 5 into equation 3. By writing this equation 3 again, you can say R1 over R2 equals square root of D2 over square root of D1. Now, anywhere you see R1, you put 1 over T1. And anywhere you see R2, you put 1 over T2. Now, let's go. R1 means 1 over T1 all over R2, which is 1 over D2. It is equal to square root of D2 divided by square root of D1. Now, 1 over T1 divided by 1 over T2 will give us square root of D2 divided by square root of D1. Changing division to multiplication, we have 1 over T1 times, you invert this fraction, T2 over 1, which is equal to square root of D2 divided by square root of D1. Finally, we can now say that 1 times T2 is T2. T1 times 1 is T1. So T2 divided by T2 over T1, T2 divided by T1 is going to give us what? Square root of D2 all over square root of D1. This is equation 6, which means we have modified this particular, the original equation from Graham's law into another equation, which is T2 over T1 equals to square root of D2 over square root of D1. That is another important equation you can use for question anytime. Now, recall again. Recall that density of a gas is equal to half of its molecular mass. This implies that density of a gas D is directly proportional to the molecular mass of that gas. We can now say that D1 is proportional to M1 and D2 is proportional to M2. Now, we can substitute D1 for M1 and D2 for M2 in equation 5. So let's go. We can now say substitute D1 for M1 and D2 for M2 in equation 6. So we write equation 6 again, which says T2 over T1 equals square root of, instead of writing D2, we write M2 over square root of, instead of writing D1, we write M1. This is equation 7. And this equation is very important to the question we are about to solve. So what have we arrived at? Summary. Graham's law says that, look at what Graham's law says. R1 over R2 equals square root of D2 over square root of D1. That is number 1. It also states that D2 over D1 equals square root of D2 over square root of D1. We can now say that R1 over R2 equals square root of D2 over D1, the same thing. Here also, we can say that D2 over D1 is equal to square root of D2 over D1. Number 3, we can also say that D2 over T1 equals square root of molecular mass over square root of molecular mass of gas 2 over molecular mass of gas 1, which is the same thing as T2 over T1 equals square root of molecular mass of gas 2 divided by molecular mass of gas 1. So these are the possible equations you can use to solve any question concerning Graham's law. These are the possible equations. So depending on the question you are given and the variables in that question, we can now say that the rate of diffusion of gas 1 divided by rate of diffusion of gas 2 gives us square root of the fraction of the ratio of vapor density of gas 2 to that of gas 1. We can also say time of diffusion of a particular gas, gas 2, divided by time of diffusion of gas 1 is equal to the square root of the ratio of the gas 2, density of gas 2, divided by the density of gas 1. You can also change it this way. At time of diffusion of gas 2 divided by time of diffusion of gas 1 is equal to the square root of molecular mass of gas 2 divided by molecular mass of gas 1. If you cannot remember this formula, you can go back and learn how to derive them. But they are easy to remember. Starting from here, this is just the primary formula for Graham's law, which states that the rate of diffusion is inversely proportional to the density of the gas. From here, you can change R1 to T1 and R1 to T2 and R2 to T1. That is just the change here. And here you just change the density to molecular mass. See you in our next class.